Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, welcome you all in Pakistan International School Taif Virtual Learning System. Today is our 59th video lecture for grade second year students, boys and girls. I'm Mrs. Rosia Imran, your mathematics teacher. Chapter number 7, I already started in previous lecture 7.1. Already I discussed with you. Today we will discuss 7.2. So according to reduced syllabus, question number 2, third part, 4, 5, 6, 7, 8, 10 and 11 is included. In 7.3, half exercise, inshallah, we will discuss today in this lecture and the remaining question in next lecture. So question number 1, second and fourth part included. Question number 2, second part include. Question number 3, second part include. 4 and 5. Up to 5 we will discuss today, and after 5, question number 7, 8, 9, 10, and 11, 12. These are included. So inshallah, this question we will discuss in next lecture. So come to exercise 7.2. Exercise 7.2. Question number 1 is, let A is 2, 5 and B is minus 1, 1 and C is 2, minus 6. Find these parts. But this question number 1 is not included in your syllabus according to the reduced syllabus. So we will do question number 2. Third part is included. Question number 2, third part. In question number 2, you have given I plus 2j minus k. V is given 3i minus 2j plus 2k, and W is 5i minus j plus 3k. Find the indicated vectors or numbers. You have to find the vectors and numbers. The third part is included in your syllabus. Third part is 3v plus w absolute. So first of all, we find 3v plus w. So 3 as it is, in place of v we put the vector v value, which is 3i minus 2j plus 2k, and then plus w value 5i minus j plus 3k. So this 3 multiply inside the bracket. 3 3s are 9, 3 2s are 6, 3 2s are 6, and this. So I will add it in I. 9 plus 5, 14, minus 6 minus j minus 7j, plus 6 and plus 3 plus 9k. So we find 3v plus w. Now we have to find 3v plus w absolute. Absolute means that the I, j and k value square under root. So 14 square plus minus 7 square plus 9 square. So we get under root 196 plus 49 plus 81. When we add them, we get under root 326. So this third part of question number 2 is included. Come to question number 4. Question number 3 is not included. Come to question number 4. In number 4, you have given find alpha, so that absolute alpha I plus 1j plus 2k is absolute is equal to 3. So you have to find the alpha value. So this is given in absolute. So you know that the I coefficient square plus j coefficient square plus k coefficient square under root, which is equal to 3. So alpha square, we open it with the help of a plus b whole square formula. So alpha square plus 2 alpha plus 1 and 2 square is 4. So to remove the square root, we taking square on both sides. So square root remove. Here alpha square plus alpha square is 2 alpha square. 2 alpha as it is, 4 plus 1 5, and 3 square is 9. So 9 shifted at the left hand side. So 5 minus 9 minus 4. Now here, throughout divide by 2 to simplify. Alpha square plus alpha minus 2, factorize it. You know that alpha square into minus 2 is minus 2 alpha square. So the factor of minus 2 is plus 2 minus 1. So alpha take common, we get alpha plus 2, minus 1 take common, alpha plus 2. So we get alpha plus 2 equal to 0, alpha minus 1 equal to 0. So the value of alpha is minus 2 or 1. Come to question number 5. Find a unit vector in the direction of v. Direction of v, vector v is given, you have to find the unit vector. So v absolute, the coefficient square under root, so 1 square plus 2 square plus minus 1 square, so we get under root 6. Now you know that unit vector we can find it, the vector divided by its magnitude. So vector is I plus 2j minus k and magnitude is under root 6. So under root 6 separately divide on each value. So we get this. This is the unit vector of the given vector. Come to question number 6. Question number 6 is A, B and C is given. Find a unit vector parallel to 3A minus 2B plus 4C. So A, B and C is given. So suppose that D is 3A minus 2B plus 4C, means the unit vector we have to find that is parallel to that. So D is 3 into, in place of A you put the value of A, and minus 2 in place of B you put the value of B, plus 4 C, in place of C you put the value of C. Then you multiply 3 inside the brackets, you get 3 3s are 9 minus 3j minus 12k. When multiply minus 2 inside, so plus 4i plus 8j plus 6k, and when you multiply 4 inside, 4i plus 8j minus 4k. So when you solve it, 9i plus 4, that is 13, 13 plus 4, 17, 17i, similarly minus 3 and plus 8 is plus 5, plus 5 and plus 8 is plus 13j. Similarly for k, minus 12 plus 6 is plus minus 6k, minus 6 and minus 4 minus 10k. Now D absolute, so to find the magnitude, the coefficient square under root, so we get 3 under root 62. So unit vector we are going to find which is parallel to D, so D divided by the magnitude of D. So unit vector D divided by its magnitude, so this is the required unit vector which is parallel to the given vector. Now come to question number 7. Question number 7 having two part. One part I'll discuss with you and the second you solve it just like the first part. Find a vector whose magnitude is 4. Already given that its magnitude is 4 and is parallel to A, this vector. So consider A is 2i minus 3j plus 6k. So absolute A means the magnitude of A will be 2 square plus minus 3 square plus 6 square. So we get 7. So A divided by A magnitude. So the given vector divided by its magnitude is 7. So when we divide, we get this. Let B be a vector having magnitude. We have to find the other vector which is parallel to this and its magnitude is 4. So it is parallel to B is parallel to A, therefore B will be equal to A. So B will be equal to this vector. So this vector 4 into the given vector, the vector which we find, so we multiply 4 and we get the other vector which having magnitude 4. So similarly you will do the second part. Come to question number 8. In number 8 you have given u, v and w represent the side of a triangle. Find value of z. Z you are going to find. So since u, v and w are side of triangle, therefore u plus v by head to tail rule. You know that in triangle head to tail rule, u plus v is equal to w. So we add u plus v 2i will be added in minus I, and 3j will be added plus 3j, and plus 4k will be added in minus k, which is equal to wi plus 6j plus zk. So here I is equal to I, 6j is equal to 6j, and 3k is equal to z. So when 3 is equal to z, so the value of z is 3. So this is the required answer. 9 is not included in your syllabus. Question number 10. Number 10 is, we say that two vectors v and w in space are parallel if there is a scalar c such that v is equal to cw, the vector point in the same direction if c is greater than 0, and the vector point in the opposite direction if c is less than 0. A part is find two vectors of length 2 parallel to the vector this B, C, and D part it having. So first is V is 2I minus 4J plus 4K. So V magnitude is 2 square plus minus 4 square plus 4 square. So we get 6. So unit vector of V is the vector V divided by its magnitude. We get this. The two vectors of length 2 and parallel to V are 2V and minus 2V. So 2V, 2 multiply with the unit vector of V, we get this. And minus 2V minus 2 multiply with the unit vector, we get this. So this is the solution of the first part. In the second part, you have given find a constant A. Find the constant A so that the vector V and W are parallel. Okay, so V and W are parallel. Since V and W are parallel, therefore there exists lambda belong to R such that V equal to lambda W. So V value we put, lambda, and W value we put, multiply with lambda. So comparing coefficient I, J, and K. So 1a lambda minus 3 9 lambda and 4 minus 12 lambda. So from second, if we find the value of lambda, that is 1 minus 1 over 3. So if you put in equation number 1, you get the value of A minus 1 over 3. So minus 3 divide here, shifted at other side, multiply. So A is minus 3. For C, find a vector of length 5 in the direction opposite to the vector V. V is given, we find its magnitude, and the unit vector of V divided by its magnitude, the vector divided by its magnitude. Now let A be a vector having magnitude 5. So since A is parallel to V but opposite in direction, so A is equal to minus V. We multiply with a negative sign. So A is equal to A magnitude into A. So magnitude is 5, multiply this. So 5 multiply, we get the answer. And the D, you solve it by yourself just like the previous question. Come to number 11. Number 11 is find the direction cosine for the given vectors. You have to find the direction cosine for first part, second part, and third part. First part is that V is 3i minus j plus 2k. First of all, we have to find the unit vector. To find the unit vector, we find its magnitude. Magnitude is the under root coefficient of the I, j, and k square and sum. So we get under root 14. Unit vector of V will be V divided by its magnitude. We get this. Hence, the direction cosine of V are, we remove the I, J, and K. Without this, we write it in comma. That will be the direction cosine of V. Similarly, for the second, we find its magnitude. We get under root 41. And then the unit vector V divided by its magnitude, we get this. The direction cosine will be I, J, and K. Remove, just you put comma. So that will be the direction cosine of the given vector. For PQ, first of all, you find the vector. How? PQ is I minus 1 minus 2. that will be I, 3 minus 1, that will be j, 1 minus 5, that will be k. So we get the vector, and now we find its magnitude by under root and square of the coefficient and sums under root 21. Then we find the unit vector pq divided by its magnitude. We get this. For direction cosine I, j, k, we remove and put comma, so that will be the direction cosine. So this was the last part which is included of exercise 7.2. So now we will start 7.3. So if I have time, so I'll complete the 7.3. Otherwise, we will do the first 5 questions. So let's see. So exercise 7.3, now we will start exercise 7.3. In 7.3, question number 1, second part is included. You have given 4 parts, but according to the reduced syllabus, only second part is included. Find the cosine of the angle theta between u and v. You have to find the cosine of angle theta. So remember the formula. The formula is the dot product of the given vectors u dot v, which is equal to u magnitude v magnitude cos theta. So with the help of this, we have to find the uh, uh, angle cosine of the angle theta. So second part is included. It is just like the first part. Look at the first part. In first part you have given u and v. Similarly in second part u and v. So first you find the magnitude of u and then magnitude of v, like this. We already find it. Then the dot product of u and v is the given vector, this. So remember, I dot I is equal to 1, but I dot j is 0. So we only take I dot I, j dot j, and k dot k, because it will give 1, and the I dot j and I dot k, all these, the different unit vector, gave us 0. So 3 2s are here. Similarly, we get 4 minus plus 3 and plus 12 we get. So we sum up and we get some answer u dot v. In this formula we put the value cos theta. We are going to find this value is multiplying here, shifted at other side, so it will be divide. So the dot product divided by the magnitude of u and the magnitude of v, so we get cos theta of the given vector. Question number 2. Fourth part is also included, so you try it by yourself. Question number 2 is calculate the projection of A along B and projection of B along A. You have given 2 parts. So first part is A is I minus K and B is J plus K. So you find the A magnitude, so that will be 1 square. J is not given, so 0 square, and k coefficient is minus 1 square, so we get under root 2. And similarly, B magnitude, I is not given, so 0 square. J coefficient is 1 square and k coefficient is 1 square, so we get under root 2. Now we have to find A dot B. So the dot product of vector A and B. So I is not given, J is, I is here not given, so 1 into 0, and j is here not given, 0 into 1, plus k is minus 1 into 1, so this will be converted in 0, this will be converted in 0, and minus 1, so we get minus 1. So A dot B, A magnitude, B magnitude cos theta. So projection of A along B, so it will be A magnitude cos theta A dot B divided by B. So minus 1 divided by under root 2. So also projection of B along A is B magnitude cos theta A dot B divided by magnitude of A, so minus 1 over under root 2. The second part you try it by yourself similarly. First part, question number 3, only second part is included. So find a real number alpha so that vector u and v are perpendicular. So remember one thing, if the vectors are perpendicular, so their dot product is equal to 0. So second part is included, and the vector u dot vector v should be equal to 0 if they are perpendicular. So alpha into 1, 2 alpha into alpha, and minus 1 into 3. So in dot product, the same I will multiply with I dot ij multiply with j, and k multiply with k equal to 0. So alpha plus 2 alpha square minus 3 equal to 0. So we get 2 alpha square plus alpha minus 3 equal to 0. Now we factorize it. 3 2s are 6. The factor of 6 which give you alpha. So plus 3 alpha minus 2 alpha minus 3. So alpha take common. So we get 2 alpha plus 3, and here minus 1 common, 2 alpha plus 3, 2 alpha plus 3, and alpha minus 1. So 2 alpha plus 3 equal to 0, or alpha minus 1 equal to 0. So alpha equal to minus 3 over 2, or alpha equal to 1. So this is the required answer. Come to question number 4. Find the number z so that the triangle with vertices A, B, and C is a right triangle with right angle at C. So question number 4 is that you have to find the value of z. A, B, and C is given, and you have given that it is a right angle triangle. So right angle triangle means that the two vectors will be perpendicular to each other. So first of all, we find the vector CACB. If you check, AC is perpendicular to BC, so their dot product should be equal to 0. So AC is, we find it that 1 minus 0 I minus 1 minus 2j and 0 minus z k. So we get this vector. And CB is minus 2 minus 0 I, 2 minus 2j, and 1 minus z k. So this is the second. So if now C is perpendicular to CB, therefore their dot product should be equal to 0. So we take the dot product. I multiply with I, that is equal to 1. 1 into minus 2, minus 3 into 0 because j is not given, and minus z into 1 minus z equal to 0. So we solve minus 2, 0 minus z plus z square. So we get z square minus z minus 2. So we factorize it. When we factorize, we get the value of z, 2 and minus 1. Question number 5. If V is a vector for which U dot I is equal to 0 and V dot J is equal to 0 and V dot K is equal to 0, find V. We have to find the value of V. V is A1I plus A2J plus A3K. This we do supposition, we suppose it. V dot I equal to 0. So vector V dot I equal to 0. So that will be A1 I dot I plus A2 J dot I plus A3 K dot I. You know, I dot I is 1, J dot I is 0, and K dot I is 0. So we get A1 equal to 0. So V dot J, again vector V and dot product with J. So I dot J, A2 J dot J, A3 K dot J. So I dot J is 0, J dot J is 1, K dot J is 0. So we get A2 is equal to 0. Similarly, V dot K, again vector V, the dot product with K. So I dot K, J dot K, and K dot K. So this I dot K 0, J dot K 0, and K dot K is 1. So A3 is equal to 0. Hence V is 0I plus 0J plus 0K, which is equal to 0, means that the null vector. Question number 6 is not included. Number 7 is show that midpoint of hypotenuse a right triangle is equidistant from its vertices. Means that you have a right angle triangle and you have given that the midpoint of the hypotenuse is equidistant from all the vertices. So suppose a right triangle OAB, let C be midpoint of hypotenuse AB, then CA is equal to minus CB. So direction is involved. So CA absolute is equal to CB and OA is equal to OC plus CA and OB is equal to OC plus CB. So OA is perpendicular to OB. So OC OA dot OB is equal to 0. OC plus CA dot product OA is equal to OC plus CA and OB is equal to OC plus CB. So we take the dot product. When we take the dot product, CA is equal to minus CB. So we put value of that. OC multiply with this and then minus CB multiply with the bracket. So OC dot OC, OC dot CB and minus CB dot OC minus CB dot CB. So this will be square and this will as it is and this, so they are cancel each other, so we get minus CB square. So they here it is negative, shifted at other side positive, so taking square root on both sides. So when we compare one with this two, so that hence midpoint of hypotenuse is equidistant from its vertices. Inshallah, next 8, 9, 10, 11, 12 we will discuss in our next lecture. Take care. Allah Hafiz.